Okay, well, our subject today is really talking about astronomy as a science, and in order to do that, we could use a few lines of discussion, but we're going to talk about how we view our place in the universe. And so we're going to look at science as a process in astronomy by looking at the evolution of our understanding of the Earth's place in the universe. So to start, we'll talk about the major theme for today, which will show up here just momentarily, I'm sure. A little spinning pinwheel of death. Here we go. We're going to talk specifically about the place of the Earth in the cosmos. So starting off, some of the early ideas that the Earth was located at the center of the universe. The heavens were perfect, the Earth was imperfect. Dovetailed really well with the early Christian ideas. This is the ancient Greek idea, starting out with that. And this dovetailed really well with the early Christian ideas that the Earth was imperfect as a result of the fall and so forth. But the planets followed uniformly circular orbits with uniform speeds. That was the belief anyway. Aristotle built on this. Instead of saying just orbits, they were actually whole spheres in this geocentric universe with Earth at the center. This is what it looked like. So here's Earth at the center. You can see all the mountains, the valleys, little stream, trees. And then you have the moon, Lunae, Mercury, Venus. The sun was actually the fourth planet. Mars, Jupiter, Saturn, and then this thing called firmamentu, which is the firmament. This is where all the stars are located. And then beyond that, you have a couple other spheres. This is just a cross-section, like looking at the inside of a gobstopper, okay? But this is what it looks like. All right, Ptolemy came in, he just adjusted it a little bit by putting the Earth a little off-center in the middle of these nested spheres, and that allowed him to predict planetary motion quite relatively effectively, and his tables were used for 1,500 years. He was the authority for planetary motion. Did it work, though? So his model looked like this. All the orbits were like this. They were these things called deferents. And they had these little epicycles. So instead of a planet moving along this orbit, here's the Earth, by the way, slightly off-center. Here's the center of the nested spheres. So instead of the Earth moving right around here along this line, the Earth actually moved along this epicycle. As it did that, it moved along this line. So it's actually kind of complicated. But that was their understanding of it, based on just what they were looking at without telescopes, space probes, and so on and so forth. So the Earth didn't move. Everything else moved, including the sun. What a mess. So it wasn't until the Copernican revolution that things really got much better. But he was a Polish astronomer. You can read all this stuff. But he came up with the heliocentric model, and he almost published it. But he didn't because he was a big, a higher up in the Catholic Church at the time, and the Catholic Church was more on the side of geocentrism because they've been using the Ptolemaic tables for so long. He was afraid he'd be persecuted. And his fears weren't unfounded. There's Copernicus there, a very reverent, devout individual. Obviously, he wasn't present at the crucifixion of Christ, but there he is. His pamphlet was called De Revolutionibus Orbium Celestium, and it was finished in 1530 and so forth. Basically recounted the heliocentric model, that the sun was at the center of the solar system, or the universe, instead of the Earth. Okay, and that's a problem, because now the sun is at the center of creation? Whoa, 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 what's going on here? The Earth is at the center of creation, as far as the Bible says. So that was the belief, and so his ideas counteracted that. But here's the Sun, Mercury, Venus, Earth with the Moon. So he had it all right: Mars, Jupiter, Saturn, and then of course the stars that didn't move. So repercussions. This idea revolutionized humanity's view of itself in the universe. Also triggered major controversy, but overall it was a more pleasing system, simpler than Ptolemy's. He got rid of the epicycles, and though it still couldn't predict planetary motion very well. So we move on to Tycho and Kepler. Tycho was a guy who had a gold and silver nose stuck on with wax because he lost it in a duel, but he was a mathematician, a Danish nobleman, well known for being quite vain, but very good at math and astronomy. There's the man right there. He discovered a new star in 1572. Why is that? Tycho's supernova is important because it showed that the universe, the heavens, weren't perfect. They change. Up until this time, the heavens were considered perfect, and the Earth was imperfect. But now, obviously, there's a new star. So the heavens change, and that was a big deal. This challenged accepted views from Aristotle and so forth. And he wrote a book about it, and subsequently was offered money to build an observatory to continue to observe things and to discover some of these things. And He talked about, used parallax to determine the distance of a lot of stars and so forth. But his legacy was really just observational. He, for 20 years, measured the positions of 777 stars using nothing but the naked eye and an instrument called a quadrant. Big deal. So, sorry about the bells. He had no big contribution to theory. It was just his data that was important. So he and his sister, incidentally, his sister actually did most of the work. At least that's how the history, but that's not really kept in the history books, but that's the reality of it apparently. There's Tycho in his observatory, and there's one of his drawings of the sun and so forth. All right. Oh, sorry about this. I don't know how this happened, but anyway, Kepler was one of his students, and he came from southwestern Germany, very humble origins, but did go to college. Came to be believing the Copernican hypothesis about the solar system or the universe, and he wrote this kind of useless pamphlet that nobody paid attention to from college about this universe in 5 regular solids. But he was a big mathematician and astronomer of the day as well, and we'll get to what he actually accomplished later on when we talk about planetary motion in the solar system. But there's Kepler. He becomes very important because he explains how planets move. Then we get to Galileo. Galileo really revolutionized the heliocentric idea, accepted it, but not publicly at first. And it's important to know he didn't invent the telescope, but was the first to use it to observe the sky systematically. So he had a bunch of contributions. You can read through these. Please pause and do so. Very important stuff. I will quiz you on it. Okay, there's his early telescope. But it was big controversy. So I'll let you read this, but basically he ran afoul of the Pope at the time. Because the church still accepted the geocentric idea, he was proposing the heliocentric idea and so forth. This is his big book that he published, went all over Europe, and the Inquisition got to him, so the printing stopped. The Inquisition wasn't all about hanging people and burning people at the stake, only a small number of people that actually happened to, and mainly in Spain. But he was put under house arrest and forced to admit his quote-unquote errors. But the big significance of the trial was a conflict of thinking about 2 ways of the universe, religious versus science. We're still dealing with this conflict here, just mainly in the U.S. When it comes to creation evolution. But it's not an old idea. At this point, though, I mean, currently the Catholic Church specifically is very much so in the realm of modern science when it comes to things. But there's just a picture of him in his trial. Finally, we can talk more about that in class, but the last guy I want to talk about is Newton. The second to last guy, actually. Newton studied all these guys. There he is. His discoveries, gravity, of course, the inverse square relation, mass versus weight, all important stuff to pause and read about. But we get to Newton helped us understand how the planets move the way they do using Kepler's laws and Galileo's publications and so forth. But it was really Harlow Shapley and Edwin Hubble in the 20th century that revolutionized our view of ourselves in the universe. Shapley only had a 5th grade education initially, but he finished high school in just 2 years. He came back to school and finished it, so good for him. But he discovered spiral nebulae that were not. He thought they were inside the Milky Way, which was the entire universe, at least thought at the time. The idea of a galaxy hadn't yet been thought up, but these spiral nebulae ended up being galaxies. Hubble proved, apparently Shapley and this guy Custis had this big debate about this, whether they were inside the galaxy or not, these spiral nebulae. Hubble proved they weren't, and therefore opened our eyes to the fact that the universe is huge and contains billions of galaxies, which contain billions of stars. We live around the sun, our star, one of billions in the universe.